Hi guys, this is just a short little video recording of the questions we did on Monday. I'll do these after every session just so that when you're going back over the questions or studying in your spare time and you forget how to do something, you can just come back to these and go, how did you do those again? Or go back to the process. So I'll go through all of the questions that we managed to get through on Monday. So on Monday we covered simultaneous equations, algebraic long division, and simplifying fractions. So yeah, I'll start with the simultaneous equations. So simultaneous equations, basically there's three types. There's the basic type with the standard three equations. That's the one they're usually going to give you, probably the easiest one. I'll go to that in a minute. Then there's simultaneous equations with just two. Now because there's two, they make it slightly more complicated. They throw in these x squareds and 2y squared and stuff. So you have to be aware of them. I'll go through how to deal with them in a minute. And then obviously you just have simultaneous equations sometimes popping up in random questions that you wouldn't think would have them. So you just need to be aware of that. So even if you think you're going to skip one of these if they come up, you still need to know how to do simultaneous equations if they come up in a question. So yeah, we'll start with B. So let's do first question B. So three-way simultaneous equations. First thing you're going to want to do is number all the equations, because you're actually going to end up with 5 equations at the end, and you're going to be subbing back into each of those equations to find other values. So you're going to need to keep these all straight in your head. Easiest way to do that, just label all of them as you go. And like when we end up with a new equation, we'll call it 4 and we'll call the next one 5 and stuff. So first things first, pick any two equations, first things first, get rid of these fractions because they're just going to be a nightmare to deal with. So if we rewrite all our equations, x plus y plus z is equal to 16. That is equation 1. And we're going to multiply this one by 2 to get rid of that 2. So new equation 2 is going to be 5x plus 2y plus 20z is equal to 40. And we're going to multiply this one by 2 as well. So this one is equation 2. And multiply equation 3 by 2. 4x plus y plus 8z equal to 42. That's equation 3. So now you can consider this like the start of the question now. So our process for three-way simultaneous equations is always the same. Pick any two equations. You can pick 1 and 2, 1 and 3, whatever. Just any two. So if we take a look at our equations, this one's probably closer to this one if we want to cancel the y's. That's what's standing out to me anyway. So let's just take equation 1 and equation 3 and rewrite them. X plus y plus z is equal to 16. 4x plus y plus 8z is equal to 42. So basically we're going to look at the coefficients of the variable that we want to cancel, and we can see they're already the same. This is why I picked those two equations, but if they weren't the same, we'd want to make them equal to the same. So if we were cancelling the x's, we'd want to make sure there's a 4 up here, and how we do that would be that we'd multiply this equation by 4. But since we're cancelling the y's and the y's are the same, we can just continue on. Next thing you're going to want to do is make sure one of the signs is, the signs are opposite basically. So these are both pluses, but we want at least one of these to be a negative. So what we're going to do is multiply either one by minus 1. So yeah, we'll just multiply the top one by minus 1 and we'll rewrite them all. So this is minus x minus y minus z is equal to minus 16. And we can keep the bottom one the same. 8z equal to 42. And just keep everything straight. If this is 1, this is 3. Then if that's 1, that's 3. So basically now what we're doing is we're adding the two equations together. And we're going to do that because when we add those two together, the minus y is just going to cancel out with the y. And basically that y is gone from our equations, and we only have two variables then to work with, x and z. So 4 minus x is 3x 8 minus 1z is equal to 7x, or 7z, sorry. And 42 minus 16 is 26. So this is what you would call equation 4. And yeah, so once you have two variables in your equation, we have x and z, you're basically going to leave it at that and call it a new equation. And what you're going to do is you're going to go back up to your original ones and pick the other equation that you didn't pick. So we picked 1 and 3. You can pick any other two, so you can pick 3 and 2 if you want, or 1 and 2. You just have to make sure that 2 is one of the equations you pick, because sorry, I just deleted something there. This needs to be 80. Yeah, so pick any two equations that you haven't already picked. So let's pick 1 and 2, say it doesn't really matter. So we'll rewrite them. X plus y plus z equal to 16, and 5x plus 2y plus 20z is equal to 80. So if that's equation 1, that's equation 2. We want to make these, so we cancelled the y in this one. That means we have to cancel the y in this one. So even though it might look easier, say this was just x and x, it might be easier just to cancel the x's, but we can't do that because we cancelled y in this equation. We need to do it in the other equation. So to make this coefficient of the y look like this, we're going to have to multiply the top one by 2, and we're going to have to make that a minus, so we might as well multiply it by minus 2. So let's just rewrite 1 and multiply by minus 2. So this is minus 2x, this is minus 2y, minus 2z, equal to minus 32. And 2 we can leave alone, so plus 2y plus 20z equal 80. And again, we're adding these together just so the y's cancel. So this 2y minus 2y is going to end up at 0. And 5x minus 2x is 3x. And 20z minus 2z is 18z. And 80 minus 32 is 5048. So another thing with these questions, I'm not doing it and I should be, is using a calculator, because any mathematical error that you make up here is going to compound, so it's just going to keep going and going, and you're going to end up with the wrong answers down at the bottom. Now, this will give you marks for knowing the process and getting some kind of an answer at the bottom, but obviously you're not going to get full marks if you don't have the x, y, and z to be the right answers. So here we have x and z, the two variables. So like I was saying before, once you have 2, you call it quits, and let's call that number 5. Next part in the process is to do 4 and 5. So your two new equations that you've gotten, you're going to put those together. So 4 and 5. So let's rewrite them. 3x plus 7z equal 26. 3x plus 18z equal to 48. So if this is 4, then that's 5. Now this worked out pretty well for us because our coefficients of the x are the same. So we can just cancel them. Now we need to make sure that one of these is minus, so let's just multiply the top one by minus 1. So let's rewrite them. This is minus 3x minus 7z equal minus 26. 5 is, leave it alone, 3x plus 18z is equal to 48. So again, we're adding these. These 3's are going to cancel. 18z minus 7z is 11z, and 48 minus 26 is 22. So z equals to 22. Now this looks like an answer and looks like we're finished, but we're actually going to want to take this and we can put it back up into either 4 or 5 just to get a value for x. 4 kind of looks a little bit easier, so let's put it in there. So if we take equation 4, that's 3x plus 7z is equal to 26. We're going to use this new value for z that we found. So that's 3x plus 7 times, sorry, my mistake, this is why you always got to use a calculator. Z is going to be 22 over 11, which is 2. So z is equal to 2. So now we're going to use this value for z. So that was my fault. 3x plus 7z is equal to 26. Now sub in our value for z. 7 times 2 is equal to 26. So that's 3x plus 14 equal to 26. We can bring this 14 across. 3x equals 26 minus 14. 3x equals 12. X is equal to 4. So again, it kind of looks like we're finished. We have two values, but we need to take these and sub them back up all the way to the start to any of our equations up here and to get a value for y. So the equation that looks easiest is probably equation 1. So let's do that. If we rewrite equation 1, we have x plus y plus z equal to 16. We know x down here, x is equal to 4. We don't know y. We know z is equal to 2. That's 16. So y plus 6, 16. Y equals 16 minus 6. Y equals 10. Again, kind of looks like we're finished. We're not finished. We need to, at the very end, sometimes they give marks for this, sometimes they don't. Sometimes they give marks for this, sometimes they don't. But just write out all 3 points. So x, y, z is equal to 4, 10, and 2. And now that's your final answer. So that is the first question we did done. And I'll just give you an overview there so you can take a picture if you want and look it over. So next we'll move on to the next question. So simultaneous equations with two equations, they give these to you when they want to be a bit meaner, and basically what you want to watch out for are these y squareds. So what we were doing in the 3 ones doesn't really work. So what we were doing, we were getting the coefficients equal to each other and they were cancelling. This doesn't really work up here because you can't minus an x off an x squared, or you can't minus an x off an xy, and same for y and y squared. So basically what you're going to want to do is take the easier equation, which is always going to have just something in x and something in y, and you're going to get x or y on its own. You can decide. Here we'll just take x on its own because it's probably easier. So let's call this, again, number of your equations. Let's call this 1, this 2. If we take equation 2, we take equation 2, 2x plus 3y equal minus 1. Then x is equal to minus 1 minus 2x is equal to minus 1 minus 3y. Then x is equal to minus 1 minus 3y all over 2. So it looks kind of complicated, but basically what we're going to do is take this value for x and sub it into equation 1. So equation 1 reads x squared plus xy plus 2y squared is equal to 4. And basically we're just going to put in our value for x. So that's 1 minus 3y over 2, and that's to be squared. That's minus 1 minus 3y over 2 times y, and that's 2y squared is equal to 4. So what we can actually do is split up these. Actually, no, we don't need to. So when you're squaring a fraction, square the top and square the bottom. Easiest way. So this is actually minus 1 minus 3y squared all over 2 squared. And this is, so we can multiply in our y here. So y times, so imagine this is y over 1, top by top, bottom by bottom. So y times minus 1 is minus y times minus 3y is minus 3y squared, and 2 times 1 is 2. And our 2y squared at the end here is just stays the same. So that's 4. Now another trick for squaring anything is square the first number, add 2 times the numbers multiplied together, and square the last number. So I'll kind of maybe use some colors to show this. So square the first, that's 1 squared, or minus 1 squared, include the sign. So minus 1 squared. The second one is going to be to add 2 times the product. So then multiply together, minus 1 times minus 3y. Make sure you include that. And then let's use blue. And then square the last. So that's minus 3y squared. So this is equal to 1. And that minus is going to come out, so that's 2. Oh, and that minus is going to cancel that again, so that's 2 times 3y, that's 6y. And because it's squared, this is going to cancel, it's going to be 9y squared plus 9y squared. So all this here is actually equal to 1 plus 6y plus 9y squared all over 2 squared is just 4. Then we can have this minus y minus 3y squared over 2, and 2y squared is equal to 4. So this is basically our equation 1 after subbing in x. So we subbed in this value for x into this equation, and we got something that looks like this. Now it's kind of messy, so what we're going to do is clean it up. And to do that, we're going to multiply by, we're going to get rid of these fractions, so we're going to multiply by the highest fraction, which is 4. So if we multiply this times 4, this times 4, this times 4, and this times 4. So those 4s will cancel. That 2 will cancel that 4 and give me a 2. That 4 will multiply with that 2 and get an 8, and that 4 will get a 16. So these 4s are cancelled, so that's just 1 plus 6y plus 9y squared. This is 2 times this, that's add 2 times minus y minus 3y squared. This is, we said that was 8y squared, and we said that was 16. So, yeah, we can multiply out the brackets, 9y squared minus 2y minus 6y squared plus 8y squared is equal to 16. Now we can just bring so get everything in order, get your like terms together. So bring your highest power y to the very left, then bring just your regular y's, and then bring your 1 at the end. And that's equal to 16. This, I forgot about this squared. So this 9y squared, that should come down. And so this will actually go into here. So that's 8y squared plus 9y squared minus 6y squared plus 6y minus 2y plus 1 minus 16 equal to 0. So that's 17 minus 6, that's 11 y squared plus 4y minus 15 equals 0. Now whatever way you like to factorize, so the factors of 11 are just 11 and 1. 15, we want to end up with 15 minus 11 is 4, so 15 and 1 are the factors of 15, and we want 15 minus 11. So these are actually our factors. So this equation here can be rewritten as 11y plus 15 times y minus 1 equal to 0. Now the only way these both multiplied together are equal to 0 is if at least one of them are equal to 0. So there's case 1 where this is equal to 0. So that's 11y plus 15 equal to 0. And this, say this is equal to any number, then any number times 0 is just 0. And there's case 2 where this is equal to 0, and this is any number, and any number times 0 is just 0. So this is y minus 1 equal to 0. So we're going to get two values for y. We're going to get minus 15 over 11. And we're going to get y equal to 1. Now, you think you're done, but you're not done. Basically, we're going to use this that we found for x. So I can actually copy and paste that. Copy. And we're going to bring it down here. And for each value of y, you're going to use this. And we're going to find the new x. So whenever you have a fraction like this, where it's one number on the bottom and two numbers on the top separated by either a plus or a minus, all you can actually do is just split it down the middle. So here x is actually just equal to minus 1 over 2 minus 3y over 2, which is minus 2 over 2 times y. That's the same thing. So we're going to sub in our value for y. Basically, I did that just so I made it easier to sub in y. Minus a half minus 3 over 2 times minus 15 over 11. So those pluses will cancel and make a plus. 45 over 22. And if you put that in your calculator, that's just 17 over 11. So that's one value of x. Now we got to get to find the other. And we know that x is minus a half minus 3 over 2 times y. Now we're going to sub in this value for y, which is just 1. So x is equal to minus a half minus 3 over 2 times 1, which is equal to a half minus 3 over 2, which is equal to minus 4 over 2, which is equal to minus 2. So two values of x, two values of y. Like we did before, we're going to want to write them all out. So let's just call this x1, y1. It's equal to minus, no, not minus. So x comes first. So our x here, 17 over 11. And our y comes next, minus 15 over 11. Same here, let's call this x2, y2. Equal to x comes first, that's minus 2, and y comes next is 1. So those are your answers. So that is second question done. So third question. This video is running kind of long, so maybe what you want to do is put me on 2 times speed or something. So it might end up being 40-50 minutes, but 2 times speed, that's 25 minutes or whatever. So that should be a manageable video. So last question. So on to the third question. So this says x minus 2, 2x minus 1 are factors of this equation here. Basically, there's two things, a factor and a root. Factors will give you the equation itself, and roots will give you where the equation is equal to 0. So we can see here that if x minus 2 and 2x minus 1 are factors, that means that x minus 2 multiplied by 2x minus 1 multiplied by some third equation similar to those would give us the equation ax cubed plus x squared plus bx plus 6. And this is basically, to find this third equation is basically what you're doing in algebraic long division, which we'll do as a last question at the end. So all these three multiplied together will give you this equation. So factors multiplied together give you the equation, and roots give you where the equation is equal to 0, so I'll explain that now. So if this equation was graphed, we'd be looking at something like this. And this is basically where the equation is equal to 0, the x-axis. So if we can write, as we saw earlier, if we can write our equation in terms of its factors, so some other third equation, this is actually equal, them multiplied together is equal, it is the equation, it's equal to the equation. And if that's equal to 0, like we were saying before, the two multiplied together are 0, at least one of these has to be 0. So we can kind of do a similar trick to what we were doing before. If we say that x minus 2 equal to 0 in case 1, 2x minus 1 equal to 0 in case 2, and we don't actually have that equation, but we could say that it's equal to 0. And when we do that, we're basically finding the x value along the x-axis that this equation crosses the x-axis. So say, okay, let's take this one example, x minus 2 equals 0, so x is equal to 2. So this basically means you have to go out 2 units on the x-axis for the function to cross the x-axis and be 0. And we can see that here, 2x minus 1 equals 0, so x is equal to a half. And that would be here. You'd have to go at half a unit for the function to cross the x-axis and be 0. And this one would probably give you that one over there. But so yeah, basically you'll be doing more functions in school later, and we'll do more next week. But yeah, so this is what we have. So these are functions. Functions plugged into the equation give you 0. So if I plug 2 into this equation, this should be 0. That's basically what a root will give you. And we're going to use this. We know x equals 2 is a root, x equals half is a root of, I'll copy paste this equation, copy, paste, they're roots of this equation. So if we sub in x equals 2, 2 cubed plus 2 to the power 4 plus b times 2 plus 6, we know that's equal to 0. It's always equal to 0 if you sub in a root. So 2 cubed is 8, 2 squared is 4, that's just 2b, that's 6 equal to 0. So that's 8a plus 2b, and 4 plus 6 is 10. Equal to 0. We say that's 8a plus 2b equal to minus 10. Now if we draw a line here, take this equation, copy, paste, and now we sub in x equal to half, and that's a times a half cubed plus a half squared plus b times a half plus 6. Like we were saying before, we know that's equal to 0 because it's a root, it's always equal to 0. So when I was saying before, if you're squaring or cubing a fraction, you can just cube the top and cube the bottom. So that's actually a times, sorry, that looks like a 9. That's a times 1 over 2 cubed is just 8. And similar here, we can square the top, square the bottom. That's 1 squared is 1, 2 squared is 4, so that's 1 over 4. Plus, what b just times a fraction is just b over the fraction. 6 equals 0. So that's a over 8 plus b over 2 plus a quarter plus a sixth equal to 0. What we were doing before, we can multiply by the highest fraction to get rid of it all. So that's a times 8 times this b. That'll cancel and give a 4. 8 times this 4 will cancel and give it 2. And that's just 8 times 6. So that's a plus 4b plus 2 plus 8 times 6 is 48 equal to 0. So that's a plus 4b plus 50 equal to 0. A plus 4b equals minus 50. So I know we haven't done functions and it was kind of a little bit of work to get to here, but you can see why I did it. These are basically simultaneous equations. This is where this is coming in. So you can see that if this is equation 1, this is equation 2. We have 2 variables, so it's kind of like our equation 4 and 5 of our 3-way simultaneous equations. And all we need to do is just put them together and cancel. Rewrite 4, that's 8a plus 2b equals minus 10. And if that's 4, then that is, or that's 5, that's 8 plus 4b equal to minus 50. So what's easier is probably to, what was I doing before? Oh, yeah, make this a 4. So multiply by minus 2. That's what okay, here we go. So if this is 4, then that's multiplied by minus 2, that's minus 16a minus 4b equals minus 20, or positive 20 because the minuses cancel. We'll rewrite 5, leave it alone. 4b equals minus 50. And we're adding these two equations together. This is going to cancel with that. 16a minus 16a plus a is equal to minus 15a. We have no more b's. 20 minus 50 plus 20 is minus 30. We can multiply by minus 1, get rid of the minuses. Then we can divide by 15, and that's just 2. So a is equal to 2, and we can go back up and sub in. This one's probably easier. Equation 4. Rewrite equation 4. 8a plus 2b equals minus 10. Sub in our value for a. 8 times 2 plus 2b equals minus 10. 16 plus 2b equals minus 10. 2b equals minus 10 minus 16. 2b equals minus 26. b equals minus 13. So we have a equal to 2, b equal to minus 13. Those are our answers. Find the values of a and the values of b, and then we're done. So we're running kind of long. If we get to it in time, I'll do the algebraic long division at the end, but I just think this is more important and more fundamental, so we'll just do this first. It might only take a second and we'll get to the algebra at the end. But like I was saying, if the video is too long, you can just skip in between the questions if you know how to do that one. Okay, so we're going to solve the equation. Basically, solving the equation means we need to find the value for x. And all this doesn't really matter. Most of the time in the questions you can ignore these. Basically what this is saying is that x can't be minus a half or a third because you'll end up with this being 0 and you're dividing by 0 and it doesn't work. So that's all that's saying. Most of the questions you can kind of ignore it. But yeah, let's get it. So solve the equation, find the value for x. What we're going to do is basically we're going to transform this into a quadratic expression, let it equal to 0, and we should be able to factor out x and find it. So first things first, let's write out each of our fractions just so we have it all laid out. 3x minus 1. We're going to bring this across. So we're going to minus both sides. So 3 over 2x plus 1 plus 2 over 5 minus 2 over 3x minus 1 equal to 0. So now when you're adding or subtracting fractions with different denominators, so different numbers on the bottom, basically you're going to want to block out. So let's start with this one. Start with the first term. Block out the one it's sitting on top of. Oh, that's not what I meant to do. Block out the one it's sitting on top of. Multiply by the other ones. So we've blocked out 2x plus 1. We're going to write this as 3 times the other ones, so 5, and times 3x minus 1. Now we're going to keep our sign. We're going to add it. We can get rid of these. Now we're moving on to this one. So we're going to block out the 5, multiply by these. So that's adding 2 times this one first, x plus 1, this one second, 3x minus 1. And we can move on then. We keep our minus, so that stays minus. Block out the one it's sitting on top of, multiply by these. So that's minus 2 times 5 minus 2 times x plus 1. And what you're going to have on the bottom is all 3 multiplied together. So x plus 1, or that should be 2x plus 1, sorry. And that would change these. 2x plus 1. Oh, sorry, it's a bit messy. 2x plus 1. There we go. So 2x plus 1 times 5 times 3x minus 1. So that's your bottom line, all 3 multiplied together. And we can't forget about our 0 at the end. So all of this is equal to 0. So basically we're turning three fractions into one giant big fraction. And to do that, we have to do that technique we were doing, block out the one on the bottom, multiply it by the other ones that it's not. So basically what we can do now is just multiply everything together. So we have 3 times 5 is 15 times 3x minus 1 plus, okay, we'll multiply this one first, then 2 times that one. So 2 times 2x is 4x, and 2 times 1 is plus 2. And we can just save that for a minute. And minus 2 times 5 is minus 10. So that's minus 10 times 2x plus 1. All over 2x1 times 5 times 3x minus 1. And that's all equal to 0. So we can continue multiplying. 15 times 3x is 45x. 15 times minus 1 is minus 15. We're going to keep our plus sign. Imagine these are linked. So 4x times 3x is 12x squared. 4x times minus 1 is minus 4x. 2 times 3x, positive 2 times 3x is positive 6x. And positive 2 times minus 1 is minus 2. Minus 10 times 2x is minus 20x. Minus 10 times 1 is minus 10. And don't forget our denominator, 2x plus 1, 5. 3x minus 1, and that's all equal to 0. Bring your highest powers of x together, so 12x squared. Then we can start with our x's. So let's just bring this one 45x, this one minus 4x plus 6x minus 20x. Then we can do everything without an x, minus 15, minus 2, and minus 10, equal to 0. This is just all three multiplied together, I just won't write it again. So yeah, add and subtract everything. 45 minus 4, 41, plus 6, 47, minus 20, 27. 15 minus 2 minus 17 minus 27 equal to 0. And now I'll rewrite all this because we're at the end. 3x minus 1, all of that equal to 0. Now, like we were doing before, to get rid of fractions, we can just multiply both sides of the equation by whatever is on the bottom of this line. But we can see that if we multiply, sorry, it's not writing for me. Pretend this is all up here and we're multiplying. We're going to multiply by the same thing over here. But these are just going to cancel, and 0 times anything is just 0. So we can just completely forget about this bottom line down here. And we can just have the equation, the top line, whatever we got in the top line, equal to 0. And we can see this is what we wanted. This is a quadratic. You can go back to factorizing, whatever way you like to factorize. Actually, first, before we factorize, we can actually divide by 3, because everything is a factor of 3. So 4x plus 9x minus 9x equal to 0. Now we can factorize 4x, 1. Sorry, no, that's 2x. 2x, 2x, 3, and 3. I've done that wrong. Oh yeah, no, it is 4. Minus 3, yeah. So we want 12. So these should be our factors. 4x minus 3 times x plus 3. Let me just check that. Yep, that should be right. So, like we were saying before, anything multiplied together equal to 0. At least one of them has to be 0, so we can do our same trick that we split it up and let both of them equal to 0. So x plus 3 equal to 0. So 4x equals to 3. X equals 3 over 4. x equals 3. And this is what they wanted. They wanted us to solve the equation, and which means basically to find the values of x, and those are our values for x. So that's the question done. So yeah, that's everything done. I don't think we'll have time to do the algebraic long division. If you find it really tough and you want me to redo it in one of the sessions, that'll be no problem. But like throughout the year, we'll end up doing that question again and again anyway, so you'll have plenty of practice at it. But yeah, I'll leave you with this. So go back, practice all those questions, take out a blank sheet, see if you can do it on your own. Then whenever you hit a snag, try work through the snag first. Then if you can't, come take a look at this video, see how I've done them, and work from there. So yeah, and I'll see you next Monday.